hear you
Yes.
well.
Okay. Yeah, thank you very much for this introduction, and I'm so glad to be here to talk about the status of PFAS in agricultural test fields here in Sweden after so many years of sludge application. So yeah, as many of us know, like we are talking today about PFAS, which is called also the forever type of pollutant. These are like pair and polyfluorinated alkyl substances, and they are found actually in household products, industrial applications, and even firefighting and other applications. Because there are so many widespread used in our society, and it has been documented that these actually are found also in the wastewater streams, in the wastewater liquid phase, and also in the sewage sludge. And many types of PFAS groups, their precursors, their they are all documented to be in sewage sludge east, also in Sweden. Why I'm talking about sewage sludge today and why it's important? I mean, we have a very big interest actually in the sector and also in the agriculture society to use sewage sludge as a fertilizer and a soil conditioner. And in Sweden, there's about 40% of the sludge is actually used as a fertilizer on arable lands. And we want to know like whether the sludge application can turn these fields which receive the sludge into a diffuse source of PFAS, and what is the fate of PFAS substances in the fields, in the soil after long-term application. Do they migrate to the groundwater? Do they stay in the soil? Are they been uptaken by the plants? So these are very important questions, not only for us, the scientists, but also for the society. So today, I'm happy to share with you some of the results that we have collecting through two types of surveillances. One surveillance targeted 3 test fields here in Sweden, which were regularly fertilized with sewage sludge over a period from 23 to 65 years. And in this first surveillance, I'm going to present some data that will help us to assess the occurrence and level of PFAS and total oxidizable substances or precursors in the soil in these 3 fields. And also it will highlight the impact of a sludge application rate on the fate of PFAS in the soil. And we will look at whether there is a possibility or signs of mobilization of PFAS along the soil profile. And then we'll look also at the degradation of PFAS in the soil after sludge, like shortly after sludge applications. So what we were doing in this project or in this study is that we collected multiple samples from the topsoil layer and from the deeper layer between 45 to 60 centimeters in the soil from these 3 fields, and we have also collected some control soil samples. These composed of sludge that is usually used from the wastewater treatment plants that usually supply the fields with the sewage sludge, but also we collected samples from reference soils. And what I mean with reference soils is that the soils that have never been fertilized with the sludge, but they are in the vicinity of these test fields. So what are these fields? We have a Lanna field in Lidköping, and here we have the sludge, which has been applied for 23 years at a rate of 4 ton per hectare per year. And here the sludge usually come from Skara wastewater treatment plant. And the second field is Iggilösa field in Skåne. And here the sludge has been applied for 40 years at 2 application rate, 1 ton per hectare per year and 3 tons per hectare per year. And here the sludge come from Shelby wastewater treatment plant. And last but not least, actually, we'll be talking about Ultuna field here in Uppsala, where the sludge has been applied for a really long time, for over more than 65 years at a rate of 4 ton per hectare per year. So you see, I was talking like the sludge application rates in these fields between 1 and 4. And actually these, the normal sludge application rate, which usually applied in agricultural soils here in Sweden, is about between 0.8 to 1 ton per hectare per year. So the application rate that we have here, they are a bit larger than what is usually applied. And here are some information about the source of this sludge and some properties. What's important to know that this sludge is the final product from the wastewater treatment plant. So it is digested, dewatered sludge, but it's not hygienized. So there was no storage of the sludge, neither some other type of hygienization. Yeah. In the second part of this study, we talked about, or we collected sample with a focus on Lanna field. There we wanted to see like what would happen to the PFAS immediately and within 3 months after sludge application. So we collected the soil, we collected the sludge and in the soil before the sludge application, and then 1, 3, 7, 30 days and 90 days after sludge application. We looked at the PFAS and the top and some other soil properties. While talking about top and PFAS, it's maybe good timing to tell like what are the substances that we analyzed. We have analyzed like a wide spectrum of substances, including like the carbonic acids, PFAS, the sulfonic acids, the sulfonates, fluorotelomere, and many others. So around like 62 substances with target analysis. We targeted 62 substances in the PFAS, and then we also analyzed total oxidizable precursor, which also summed to 60. We targeted 62 substances again. With this introduction, I will now start maybe talking a little bit about first the reference substance, the reference samples that we had. We start talking with the PFAS in the sewage sludge that we collected lately from the wastewater organization providing the fields with the sludge. So we have sludge from Skara wastewater treatment plant, and we have it from Kongsvingsverket wastewater treatment plant, and Skara providing Lanna field and Uppsala providing Ultuna field. And as you see here, we found that between 28 to 60 nanogram per gram of total solids of PFAS was found in these sludges. And you could see here, like in Lanna field, like the PFAS that we have analyzed was dominated by perfluorophosphonic and phosphonic acids, while and some other, of course, some other PFAS. While in Uppsala, the levels of PFAS was lower than what is found in Skara, and it's mostly dominated by some like mother substances of PFAS. I mean, it's probably, I would say for me, it's not really surprising that the latest sludge in Uppsala is like contains lower concentration than the other sludge. It's because like the upstream work that Uppsala Vatten has been working a lot with to decrease the PFAS contamination from there. So these results, they come from the 62 substances that we targeted in the target analysis. But how does it look like if we compare these target substances with the top analysis? And here what you see, we found that the top analysis showed like higher concentrations in the sludge, in both types of sludge. I would say for this, like the sludge, it's higher than what is found in the targeted analysis. And again, you could see that the phosphonic and phosphonic acids, fluorinated acids, they are like dominant in these, but also we have fluorotelomeres also found in the top. Probably the top substances, they are in terms of in the case of Skara, they are maybe 10-15% higher than the targeted PFAS, while in Uppsala, the hidden PFAS substances found in the top, or as shown in the top, they are almost like 50%. So this means that still, like, what we don't see in the targeted analysis does not mean that these substances are not found, but they are there and they could be leaked or found in the future. Yeah, I think now Raed will continue.
So, hey, so as you see, can you move? Yes. Here the comparison between the result from target analysis to the right and from top, where we applied on sludge samples. We see that the amount of perfluoroalkyl acid increased when we applied at top, and it's like something expected. We see increasing of fluorotelomere base precursors, which is intermediate product that will appear during the oxidation. And I want to say something that we apply 9 doses of oxidants on those samples to achieve this result. And as we see, even after applying 9 doses, there is still precursors that not oxidized, and this related to the presence of different organic compound in the sludge that will consume the oxidant and prioritize for this oxidation. And this is something that we are at IVL in our lab. We are working to establish method for applying top and to consume those amount of organic compound. Yeah. Next slide. Here in the next slide, we just a minute. Yeah. We are talking about the PFAS dominant in this perfluoroalkyl acid that results. As we see, we have different type of perfluoroalkyl acid, and it's more of those short chain from hexa carboxylic acid and penta and propan. This may show us the tends to move from long chain PFAS to shorter chain PFAS, especially during the last like maybe 15 or 20 years. The next slide. Here, we have the result from the reference soil sample, where here we don't apply any type of fertilizing. We see the presence of PFAS in those soil samples, but it's like maximum 1 nanogram per gram dry weight. And this, we assume that it's related to precipitation from rain and air that accumulated on the soil. And the result is showing those amount of PFAS in Lana and in Lidköping, in Igelåsa in Lund, and Altona in Uppsala. Next slide. Here a comparison between applying top and target analysis to the right of those reference soil sample were not applied fertilizing with sludge, and to the left, the top result, we see increasing of perfluoroalkyl acids up to 3.5 nanogram per gram. And this related, of course, to some PFAS that we are not able to analyze with the traditional target analysis. Then we go to the next slide, where here, can you move to the next?
Yeah, I think it's
Here we have the result from soil fertilized with sludge. We see that we are like in the lowest one in Lund, Igelosa, where it's around 5 nanogram, where in the reference soil was around half nanogram per gram. And in Lana, it's go up to 10, and in Uppsala, Altuna, it goes to more than 50 nanogram per gram. And we can see the distribution of different PFAS, perfluoroalkyl substances, and also the precursors, where it's clearly represented in these samples. I'm trying to go quickly to cover the topics. Next slide. Yeah, here a comparison from application of fertilizers, and where we apply top to the left result, we can see that clearly increasing more than 3 times of the total PFAS. Also here we apply also 5 doses of oxidant, and in spite of that, we still seeing a precursor represented in the result from after applying the top, and this related also the same problem that there is a lot of organic compound in the soil that will prioritize for this oxidation. In this, like we can see that in Uppsala field station, Altuna, it goes up to around 140 nanogram per gram. In Lana from Lidköping, it's go to 40, and in Igelosa, it goes to a little bit more than 20 nanogram per gram. And this was clear how much we have PFAS that is hiding, or we are not able to analyze through the target analysis, and can be degraded by the time and forming the related perfluoroalkyl substances. The next slide. Here we can see the composition of those PFASs. We see PFOS related dominant in like a sample from Uppsala, from the field station. And we see also after applying top, also almost we have the same amount of PFOS before and after, and we can assume that this is relating the regulation that applying using PFAS is banned. And not just PFAS and PFAS precursors. And we see related alkyl substances, the shortage of PFOA and other that formed after applying top. Yeah, the same pattern, we see it also in Igelosa and Lana field stations. The next slide.
Yeah, so maybe I can help you now from now on. Yeah. Okay. So yeah, I mean, with the previous slides, we just see like a very clear trend that the longer the history of sludge application rate on the fields, then the higher the concentration of both the total oxidizable precursors, but also the targeted PFAS substances. And this is so interesting. So what we want to continue to look at, like, what is the impact of the sludge application rate on PFAS in these soils? So again, I just want to remind that, as I mentioned earlier, like the sludge is usually applied in Sweden at rates of 0.8 to 1 ton per hectare per year. And this depends on the sludge content of phosphorus and also the heavy metal. So if we don't have really like limitation on these, we would apply 0.8 to 1 ton per hectare per year. And now this is what it looks like to assess the impact of the sludge application, we looked in Igilosa, and there we have 3 applications. So the control soils, no sludge application at all, and then we have 1 ton per hectare per year and 3 hectare per year. And you see here clearly there is like a linear relationship between the sludge application rate and the concentration of the PFASs in the soil. And this applies to the individual PFAS and also the top substances. So the higher the application, or the higher the application rate, the higher the concentrations of PFAS, and that's make just like a very clear sense, because like the higher the application rate of sludge, the bigger the mass that we apply in the soil. And since we know that most of the PFASs, or many of them, they are really persistent, they are accumulative. So if they don't degrade, if they don't break down, if they don't leach, then they will stay in the soil. And that explains the buildup at the longer history of sludge application, but also at the higher application rates. And yeah, another thing that also we want to see, how does it look like if we go deep in the soil? Will we find also PFAS there? And yeah, so this is also what we did. We targeted Lanna field and we collected soil from the top layers and from the deeper layer. And we did this analysis of top and the targeted analysis. And we have also a very clear trend that the top soils, they are the soils which receives the sludge, and there, most of the PFAS will be accumulated in the top and also in the targeted analysis. And as we go deeper, probably there will be some migration, and therefore we will find some PFAS in the deeper layer in both the targeted and the PFAS. The thing is that the deeper soil layers, they show a detectable concentration of these substances, and at significantly higher than what we expect to find in background soil and reference soils, like soils with no really sludge application, or like, yeah. And this behavior of finding PFAS down in the soil, this probably is a clear sign that some of the PFAS might even migrate into the deeper soil due to leaching with the soil water and so on. So we have some understanding now, or at least what would happen, or the behavior, and like whether these soils like accumulating and have elevated concentration of PFAS at surface layer and deeper layer, how that relate with sludge application rate. And finally, we want to see really what would happen shortly after sludge application in these soils. And here you find a slide from Lanna where we have the sludge. We have the soil in the control soil, but also soils at different times, at 0 day before sludge application, 1 day after sludge application, 7 days, and 90 days. And we could see like probably within a week, we found a slight decrease in concentration of PFAS in the soils, while after 3 months, there's like a slight increase in the PFAS. We are trying to understand this behavior. Probably we thought like initially that probably some rain has occurred and lead to leach out of PFAS from the topsoil. That's why it decreases during the first week. And the increase after 3 months, that could be explained by degradation or breakdown of some of the precursors. So because of that, or to clarify that, we collected some rainfall data in the same, like in the rain station at Lanna, covering the time period, the same one as during which we collected these like PFAS data. We found that there's some rainfall during like the entire period. So there could be some leaching. We are not sure like whether the first rain that happens during the first week would really have this significant impact of decreasing of leaching out or decreasing the concentration in the upper soils. And yeah, since there's also like rain, we try to think like, is there like during this rain would be some waters or leaching PFAS, or bringing PFAS, washing out PFAS from other sites and accumulating in our soils. We are still trying to understand what's going on during the short-term application. So yeah, I mean, now we are like coming to the conclusion. Apparently, like extended sludge fertilization at rates exceeding 1 ton, even 1 ton, may lead to elevated levels of PFAS and top in the soil. And this also, like we found that PFAS is a dominant in most of our samples. And as you saw, like there's a direct relationship between the sludge application rate and the concentration of PFAS and top in the soils. The higher the application load, the higher PFAS and top we find in the soils. And there's some science suggesting that PFAS in the soil could migrate from upper layer into deeper layer, indicating mobility. And finally, last but not least, precursors. They seem to be really contributing significantly to the PFAS pool in the soil. What we see in target analysis is only a small portion of what could be potentially found in the soil in terms of PFAS pollution. With that, I would extend my appreciation to the financial support from the Naturvårdsverket and from Wastewater Organization, and also thank my colleagues at IVL for being part of this project. Thank you very much.
Thank you very much, Sahar and Raed. We are actually running high in time. Probably we will have an overdue in time. But yeah, please, if there are questions, ask in the chat. I actually got stuck with the question myself. I will ask it in the chat for you. And please, Sahar and Raed, just follow the chat a little bit and see if you can answer the questions if coming in. Thanks a lot again. Meanwhile, Linda, om jag kan be dig att dela nästa presentation om Omställningslabb för hållbar hantering av PFAS i Sveriges största vattentäkt, PFAS-fritt Mälaren.
Yes, det ska jag göra. Så.
Du hörs lite för lågt, men
Jag har inte hunnit säga så mycket än, men har ni mig bättre nu?
Nu hörs det. Bra.
Ja, härligt.
Tack. Vi ser din presentation. Så
ja, vad bra. Tack. Jag blir tillfrågad att komma och delta idag för att berätta lite om ett projekt som vi har försökt söka finansiering för i den här Omställningslabb Waterwise Societies. Och vi fick ett fint bidrag från VA-kluster Mälardalen för att skriva ansökan. Och som ni ser hade vi en ganska stor ambition. Vi kallade projektet PFAS-fritt Mälaren. Omställningslabb för hållbar hantering av PFAS i Sveriges största vattentäkt. Vi samlade ihop en väldigt stor projektgrupp och de logotyper ni ser här längst ner, Uppsala vatten, Swedavia Airports och Käppala och så vidare. Det är de projektparter som var med i det första projektet som då ledde till att vi senare skrev den här ansökan. Ska se om jag kan byta slides. Jag tänkte lite börja då vad som var själva motiveringen till att vi gick in med den här ansökan. Och det var för att vi i ett steg 1-projekt träffades inom ramen för vad vi då kallade detta projektet att heta samverkan och åtgärdsplan för hållbar hantering av PFAS-föroreningar i Sveriges vattenresurser. Och vi var, som ni ser, ett antal deltagare redan då från början, samma från förra slide. Och det som motiverade eller som vi ville göra redan i det här steg 1, det var att titta på det faktum att vi vet att det finns PFAS i Mälaren, inte en stor överraskning för alla er som lyssnar här. Men vi kan också se att med de nya dricksvattendirektiven så blir det en stor utmaning. Och jag vet att det är några som lyssnar här till exempel från SVOA, för visst känner ni till att det finns en rapport som är gjord på östra Mälaren av bland annat Frida Ekman från SVOA men också Helene Ehed från Norrvatten. Och det var detta som tyckte vi var motiverande till att arbeta vidare med den här frågan. I den rapporten så tittade man ju på hur olika PFAS-källor bidrar till halterna i Mälaren. Och vi vet ju också att samtidigt som det finns då PFAS så finns det också vattenverk som förser väldigt många miljoner människor med vatten i den här miljön. Och den här rapporten som jag är säker på att ni känner till, jag ska inte lägga så mycket tid på den, det här är lånade slides dessutom från SVOA och Norrvatten då. Men det som man kan se är ju att det klart finns påverkande aktiviteter omkring de här vattenverken. Vi kan också se att det finns flöden som man behöver känna till, och det är ju fint markerat här med pilar, och man kom fram till att just den östra delen av Mälaren är viktig att titta på. Jag ska inte gå in på detaljer som jag sa, men jag kan säga att den här kartan visar lite hur de olika massflödena som de kom fram till i sin beräkning när de använde sig av en modell där man tittar på vad som flödar som har gått ut och in. Och när man då sätter ihop det i den här cirkeldiagrammet så kommer det ändå fram till att det finns en ganska betydande andel av en okänd källa. Och vi hade gärna sett att man i ett nästa steg tar sig an fler delar av Mälaren, inte bara den östra. Så det var en ambition vi hade i det stora projektet, i den ansökan som vi skickade in. Och vi satt också tillsammans och tittade på vad är det för kunskap vi har idag när det gäller PFAS-frågan. Vilka kunskapsluckor finns och vilka är viktiga då och betydande att fylla i. Vi genomförde en workshop, flera stycken, och även enkäter som där vi skickade ut till berörda. Ni har säkert mottagit den, flera av er. Där vi ställde frågor kring vad man tycker är de prioriterade områden att jobba vidare med framöver. Och det som själva steg 1 mynnade ut i var att vi kunde se summerat en framtidsvision för hur vi vill att Mälaren ska stå i framtiden. Och till exempel vill vi att PFAS inte ska utgöra någon risk för människor eller hälsa eller miljö. Vi vill ha noggrant kartlagt vilka PFAS-ämnen och hur de rör sig i Mälaren. Och där ska vi såklart också ha en bra övervakning. Vi ser gärna att vi hjälps åt med ansvaret och att vi fördelar det på ett rättvist sätt. Och vi hade också gärna sett att det fanns en nationell samarbetsplattform där man kan träffas för kunskapsutbyte, samordning och framförallt av åtgärder av PFAS. Och det projektet som vi skissade på och som då tyvärr, nu ser jag att det blev en dålig kopiering här, men det här Waterwise Omställningslabbet fick tyvärr inte finansiering. Men vår tanke med det var att vi genom olika typer av utvecklingsresor som visas här i mörkblått var att vi skulle ha en utvecklingsresa där vi tittar på Mälaren i det naturliga vattnet. Men vi hade också sett att vi ville göra en utvecklingsresa i lite mer tekniska system. Och vi hade ju då partners med dels från avloppsreningsverk, också dricksvattenverk och avfallsanläggningar. Och då hade vi en ambition att de här olika testmiljöerna ska bidra till arbetet kring samverkan, kring policy och kring beteendeförändringar. Och vi hade ju ett jättefint stöd av Mälarens vattenvårdsförbund som gick in som koordinator och huvudsökande i det här projektet. Så vi hoppas att vi kan formera om oss och titta på nya möjligheter framåt. Och det var det jag tänkte berätta om det projektet. Och jag tänker också att ni jättegärna får ta kontakt om ni har fler frågor. Och återigen ett jättestort tack för att vi fick möjlighet att få finansiering från er för att samla oss. Och jag ska också säga att även om vi inte fick finansiering den här gången så har vi samlat ett jättebra... Vi har lärt känna varandra och vi har identifierat väldigt många superduktiga VA-organisationer runt omkring Mälaren som vi jättegärna samarbetar med framöver.
Tack så mycket, Linda. Tusen tack.